Mr. Samuels here with a quick lesson on balancing chemical equations. When we're talking about balancing chemical equations, we're talking about writing in coefficients so that the number of each element is the same on both sides of the equation. There's a little explanation of this on page 224 of your book. They show you a method for balancing that's a little different than mine. Either one works, and the beautiful thing about these is you'll be able to check your work in the end. So whatever method works best for you, but this one is the one I have the most success with, so check it out. Step one of this method is to start with an element that appears twice. I'll explain more in detail in the next example. Then you're going to write in coefficients that balance that letter. So here, if there were no coefficients here, we'd have two oxygens on the right, but only one on the left, so we need to add a coefficient of 2 here so that there's two oxygens on each side. In this case, the two oxygens are separate. In this case, they're bonded together in one molecule, but we still have the same number of atoms. Step 3, balance elements that only have one missing coefficient. So after that first step, if you had 2 blanks with hydrogen, for example, we can't do that next. We'd have to do something that only has one missing coefficient. Now, once in a while, you're going to get stuck. And if this happens, you're going to multiply your coefficients by the subscript of the missing term. Let me explain what that means. So here you can see at the bottom, after that little slide thing disappears, that we have 2 oxygens on the left, and that O3 on the right is going to be tricky. Because if I put a 1 here, that's going to give us 3 oxygen atoms. If I put a 2, that's going to give us 6. Shoot, we are stuck. If stuck, multiply your coefficients by the subscript of the missing term. So this was the missing term, the one that was giving us trouble. The subscript here that we were stuck on was 3. So I'm going to multiply that 1 by 3. I'm going to change it. So now look what happens. We've got 6 oxygens, 3 molecules with 2 O's each. So now it's going to be much easier to balance this. To get 6, we're going to need 3 times 2. So you'd write a 2 there, and then we'd have 6 on both sides and be balanced. Let's look at a real example. Here's a reaction between zinc and hydrochloric acid. You guys did that in the lab. That was the fizzy bubbling fun that you guys saw in semester 1. But at any rate, what I want you to see is that we can pick any element here for step 1. It says pick an element that appears twice. Zinc appears twice, hydrogen appears twice, chlorine appears twice. So I'm just going to start with zinc. Step 2, write the lowest whole number coefficients to balance that element. And you see here, there's 1 zinc on each side, so 1 and 1 will balance zinc. Next, choose an element that only has 1 missing coefficient. We want to balance not H this time, because look, there's 1 blank H here. Oh, there's another missing coefficient for H. There's 2 blanks next to H. So we're going to do chlorine first. 2 chlorines on the right side means to balance this, we'll need a subscript here of 2. 2 chlorines, 2 chlorines. Now there's only 1 blank for H. We can do H, 2 H's on the left. To get 2 on the right, we're going to need 2 times 1. Now this equation should be balanced. Let's check our work. What I like to do is under the arrow, make a list of the elements present and kind of go through an inventory of each. We got 1 zinc on the left, and look at that, 1 zinc on the right. We got 2 hydrogens on the left, and lo and behold, 1 times 2 is 2, 2 hydrogens on the right. 2 chlorines on the left, and you guessed it, 2 chlorines on the right. That means this equation is balanced. Now if this was a 4 or something, it means you have the wrong coefficient or you counted wrong. Check your work again. Change what you need to. And also remember that sometimes you might get bigger numbers, like 2, 4, 2, 2. Now that'll still balance, but be careful. We could have 100, 200, 100, 100, and it would still balance. We don't want that. We want the lowest whole number coefficients to balance. So if you can divide them all by 2, for example, please do so to get your final answer. Let's look at another example. This should look familiar. This was the combustion of hydrogen, the exploding balloon demonstration I showed you. Step 1. Look at your notes for this. Balance an element that appears twice. Hydrogen. Indeed, lowest numbers that balance that coefficient. Step 2 are again 1 and 1 because they had the same coefficients. If this was, if there was no a subscript here, we would need 2 to balance that. All right, now there's only 1 blank for O. Let's do O. 1 oxygen on the right. If I Uh-oh. If I put a 1 here, I'm going to have 2. Well, shoot, if I put a 2 here, I'd have 4. Oh no, we are stuck. If stuck, step 4, multiply your coefficients by the subscript of the missing term. This is the one that was giving us trouble, so we're going to multiply these 1s by 2. We're going to change them. Now, watch what happens. H stays balanced, but look at this. 2 O's on the right. We can fix this with just 1 O on the left. Now if we check our work, this equation should be balanced. All right, let's check our work. 2 times 2, 4 H's on the left. 2 times 2, 4 H's on the right. 2 times 1, 2 O's on the left, and lo and behold, 2 times 1, 2 O's on the right. All right, so there's lots of practice problems in your notes here. Give those a shot. Thank you for balancing chemical equations.